Good afternoon. I'm happy that there's still some listening and following the presentation. My name is Wolfram Rinke. We did this research work together with Britta Niklas. She was initiating that work, and she's the expert marketing and wine economic expert, and I'm the technician. So I was doing the data analysis here. We are talking today about the main idea of the presentation was developing a hedonic model which incorporates weather conditions or environmental parameters in addition to the traditional parameters used in hedonic models. And the main approach here was not using the classic regression process. We used nonlinear modeling techniques used traditionally from artificial intelligence. So we use machine learning algorithms to generate the model. Here a little bit survey of the data. So we had data from Gomio, actually of 13 wine regions, and altogether we had a lot of data sets. The data set in total was about 17,000 samples. We cover red wine and white wine and a lot of different grapes, and all over the wine regions in Germany you could see here on the map. The weather conditions we included in the model is, on one hand is the sun, temperatures, mean temperatures, precipitation, and days of frost, for example. Here are some typical graphs over the time period we were looking at, and the question we had: how strong is the impact on wine prices? And we were also looking on the impact of Gomio points. So is there an impact on Gomio points in relation to changing weather conditions? So the summary of the data: so we had a time period from 1989 to 2013. We had both red and white wines. So the red wines was less represented than the white wines, and some descriptive statistics of the two parameters we were looking at, like Gomio points and price, bottle prices, which we used here between red and white wine to give you an idea. So how about the model building? As I said before, we will use nonlinear technology. So it is a traditional multi-layer neural network. It's a sort of simulation of the brain to do the function mapping between the independent and dependent variables. At the end, you end up with a model which is more or less seen as a black box. You have no explicit function description like you have in a traditional regression. You can look at this black box model using different approaches to find out the impact or the importance of parameters from the independent to the dependent variables, and also you can use it for simulation of the parameter of the analyzed system. So the model itself ended up with 26 independent variables. We found out, or we looked at different price ranges. So we had separate models for low price range and high price range, and we also separated the model for red wine and white wine. So at the end we came up with 24 different models, and we were also separating the models based on the grape. So we had 3 white wine models with 3 different white grapes, and the same for the red wine. So we took those data sets which were most represented for the model building. On the right side you see the list of parameters we were using. So how did we analyze the model which we received at the end? We use 2 different parameters to give us some information about the impact or the interrelationship. One is called the dependency factor, which is a parameter which expresses the importance of an independent and a dependent variable. It's derived from the sort of sensitivity analysis of the network, and the average elasticity, which we also derive directly from the network. So we are not using a table, elasticity table, so we use the derivative function directly from the neural network model. And so the results of these, after the models have been trained and built, so this is the mathematics. I skip over this one. So these are the results for the models generated. So this is the dependency factors for the low price range on red wine for all three grapes. So these are the grape types we used here: the Frühburgunder, Spätburgunder, and Blaufränkisch, depending on the different importance of the parameters used in the model. And it's the question we had in the beginning was to find out the differences between each of the models. So are there really differences between low and high price ranges between the grapes? Are these differences really significant? So what you can see from the graph here, looking again at the low price range and the red wine and the high price range, you could see significant differences and importances of the parameters. So for example, when we look at days of frost here, so days of frost here is important for Früh and Spätburgunder. If we look at in the low price range, if we look at the high price model, days of frost has lost its importance in that observation. Then we did the same for white wine. So the picture overall is a little bit different than in red wine, and the same again for low and high price range. Again, high price range has less significant or important parameters like the low price range. Then we were also interested to find common parameters in the model building, so we calculated also the average elasticity on the prices for red wine and white wine, and we found, you will see that there are two parameters which are extremely significant or extremely sensitive for all the models. These were sun growing and precipitation growing. For the red wine, and these are the detailed numbers, I skipped this one, and the white wine model actually produced the same picture, so the same expression. So again, sun growing and precipitation growing has the same or the most sensitivity on this calculation. Again, we calculated the elasticity, also for the Gomio points. Here's the result for the red wine. Again, sun growing and precipitation growing is here a common significant parameter, and the same picture we see here also on the white wine. Then we looked at the models, running simulations over the models to see how is the values distributed over the value ranges, what is the impact on the prices, are they linear, are they non-linear, when they are non-linear, where are they linear, are there some maximums or minimums, or continuously decreasing, increasing. So we took the days of frost as one parameter and its impact on the wine price. So here in comparison we have for the left side the red wines for all models and low price, high price, and the same on the white wine. Again, low price, high price for all the three analyzed wines. You could see that, for example, the high price Weißburgunder here has a maximum price impact on days of frost, which means that it the price value will increase up to a certain amount of days of frost, and then if it goes over that range, it will decrease in the price value. The same for red wine, shows a little bit different picture. Again, red wine and white wine again for the other parameter, sun growing. So we were looking also at the parameters we had before sun growing. How much sun do we need to increase, to see the impact on the price? Typically we have an increase in the price range, but it's not all over for all wines, and it's not the same for high and low price ranges. The same for the Gomeo points. Also we did the simulation for the Gomeo points to see the impact on sun growing. Again for all the models. And we were also looking at the air temperature maximum in the growing phase, and also got different pictures for all the different grapes. What I forgot to mention before, for the we were looking over the growing period, over the whole period. We separated the environmental conditions, the air conditions, air temperatures in a sort of winter phase, the growing phase, and the harvesting phase, and separated these parameters, which were collective averaged parameters in that time frame. So what's the conclusion? The conclusion is that there is no generic single price equation for all the different kinds of wines and models, which you could see from the simulations very clearly. And the other conclusion, which was very interesting for us also to see, that there are at least two common dominant variables which are interesting in looking at the elasticity and the price and the Gomeo point models. So these two parameters, sun growing and precipitation growing, seem to have a very generic characteristics here. Okay, so that's it. Thank you for the attention.